All right, and we're starting out now 05I-60. We have a square and a circle. I'm going to switch my color to yellow. Let's try yellow this time. So, square and a circle. I don't know if I like yellow. I'm going to use black. I haven't used black yet. Let's see how that looks. I don't really like that either. I'm kind of picky. Well, I mean, we'll go green. I think green's okay. So, we have the side length of a square, 0.261, oh sorry, 2.61. And we know that this point right here is the midpoint of a circle. It's the midpoint of a side, I meant midpoint of a side. So since it's the midpoint, the side length is split in half, right? So that becomes 1.305. I'm not a very mental math kind of person, but I'm pretty sure that's right. And then this side, of course, is still 2.61. Now, what I'm thinking to how to solve this problem is we can make just this right triangle here, this right triangle, and then somehow subtract this area in here. So first, let's just find out what the area is, the entire area of the triangle, right? This entire, every bit of it. And that entire area is just these two multiplied together divided by 2. So in essence, it would just be a fourth of the area of this entire square then, because you have half of it, then you have half of the length of the square, you have the full length of the square, and then of course you'd have to divide it by 2 again, which gets to a fourth. So let's do 2.61 squared divided by 4. So that's the area we're working with. That's the area of the entire triangle. Now again, how could we figure out what that angle is right there? Let's think. So if we have this right here, well, we could just draw a line right here. Again, since it's a midpoint, we know that must be perpendicular to that side. And then what about this angle right here? Hmm. Well, that I'm not so certain about. But if we can figure out what the length of this side right here is, uh, then we could have our answer. All right. So again, we drew our segment here, a line. Now, as I said earlier, this right here, this angle must be 90 degrees, right? Because it's perpendicular. The center of the circle has to be perpendicular with the midpoints, right? Now, since that has to be 90 degrees, if we find the angle of this right here, of this triangle, and have subtract it from 90, we get the angle of this side right here of the triangle. So the importance of that is once we find that angle, we already know the two radii, we can figure out what that opposite side is real fast, right? Let's do that. So that angle right there, looking back on our sig from our trig from yesterday, we have the opposite side and the adjacent side. So that's just tangent, right? Specifically, it's going to be inverse tangent because we don't know the angle. We're trying to solve for the angle, but we know the sides. So inverse tangent of the opposite side, 2.61 over 1.305. I'm just going to simplify that to be 2. Inverse tangent of 2, because the opposite side is double the length of the inside. So if we plug inverse tangent of 2 into our calculator and make sure we're in the right mode, I guess it doesn't necessarily matter, but I would like to work with degrees. What did I not plug that in right? Yeah, we're still in radian. I switched to parametric. I made a mistake. Okay, let's try that again. So 63.4 degrees. And again, if we subtract that from 90, we get what that angle is right there. That angle, I'm going to switch back to green, orange. Let's do orange. We're just in green. That right there is 26.565. 565 degrees. So I'm just going to quickly use the law of cosines. We used it on an earlier, actually we used it on an earlier problem on the same page. You can see the law of cosines up here if you're unaware, if you're unfamiliar with it, or check the problem 05G-60. Since we've already gotten some practice with it, I'm just going to immediately plug it in. Uh, and I'm going to simplify it a little bit since these two sides are the exact same. Instead of doing that squared plus that squared, I'm just going to do 2 times one of those sides squared. 1.305 squared, and then plus, or sorry, it would be minus, and again, it's just going to be 1.305 squared for this one. Since you're multiplying the two, you might as well just square it. Cosine of the angle. So 26.565. Oh, okay. Never mind. That's not the angle. The angle is actually going to be 180 minus 2 times that. 26.565 times 2. Because how I have it set up right now, our C value is going to be the hypotenuse, the opposite side right here. There it is. That's what our C term is going to be. I could have just plugged it in straight like that and just taken the square root of it, but since I'm already here in the numeric solver, I might as well finish it out. And we're just going to say that's a squared is equal to all of that. And we're in degrees, so let's see. All right, so we have that length now, 2.33. I think that's a valid answer. And now what we can do with that, if we make a triangle right here, right triangle, there we are. Since we know the length of this, we can quickly figure out what that height is, and then we can find what the area of this triangle is. All right, so we have the base. I'm just going to divide it by 2. So that's, I used A. Never mind, I used A. A divided by 2. So that's 1.167228 right there. Now, again, we have an angle and we have a side. We also have a hypotenuse. I'm just going to quickly use the hypotenuse and multiply it by the sine of the angle. So 1.305 multiplied by the sine of the angle, 26.565, yields us 0.0836127 roughly. So that's the height. We're going to multiply it by the length of this bit right here, and that will give us the area of this entire figure right here. Okay. Now the importance of us doing that now is now if we find the area of this entire segment, okay, which I'm going to do quickly, if we find the area of that entire segment, then multiply it then subtract it from this area, we'll figure out what this inner area is. Okay, so as we said, that angle is 26.565 times 2. That right there tells us that this angle right here is 127.87 roughly. Divide that by 360, multiply it by 1.305 squared in pi. All right, that will give us that gives us the area of this entire segment, and subtract it from the area we just found. And now we have what this area is, 1.2 roughly. And again, if we do I'm pretty sure it's all the way at the top. If we find it here, it should be, yep, this right here, 1.70 minus 1.20 yields us 0.499. And that is our correct answer. So I'm pretty sure it would have been faster instead of me using the law of cosines. If I were to use the law of just normal trig and keep using this right triangle, I could have just said this side right here, this little bit was just the angle, the cosine of the angle multiplied by the hypotenuse, which is the radius. I could have done that. I probably should have in hindsight, but we still got the same answer. So I already am aware of that shortcut. I should have done that again. I apologize for slowing this down a little bit, but I mean, it's still a good refresher to use the law of cosines. I mean, you can't always make a right triangle, you know, so I feel like that was good practice. So we know that this shaded area is 0.499. Alrighty. Well, you can go ahead and look at 06I-60. I guess we're in a new year now. And you can place your guess in the comments below for what you get. And I'll be back tomorrow with the answer. So thank you all for watching, and y'all have a great night.